Hi friends, I believe that the first two scenarios, scenario 1 and scenario 2 were helpful, and now we are directly going to jump into the GNS3 to demonstrate this scenario 3. Please have a look at this, and we are going to check how the ping flows from PC1 to PC2, alright? And in my right hand side, you guys can see this, ICMP echo request and ICMP echo reply. So in each and every hop, I'm going to show you what are the fields will be populated here. All right. Now, just for an instance, let's assume this PC1 MAC address is A and this PC2 MAC address is B. Just an assumption because I cannot enter the whole MAC address inside those fields. And for your information, the fields which I have marked here, these are only important fields for the ping process. If you have a look at the actual frame structure, it is going to contain some other fields as well. Same thing applies for IP header as well. The IP header contains lot of other fields, not only source IP and destination IP. Similarly, ARP header also going to contain lot of other fields. But just for an example, I am using some limited fields to make the ping process easier. From PCA, I am hitting the command ping 30.0.0.10. So these four structures, let's assume these four structures are created. Now what will be your source MAC here? Source MAC is going to be A. What is that destination MAC? This is the first time I am initiating the ping in PCA. So obviously the ARP cache is going to be empty. Let's have a quick look at that. So this is the PC console. Previously I tested it, but I have cleared the ARP. Let's check the ARP again. Show ARP. The ARP table is empty. Fine. So when you initiate the ping 30.0.0.10, this PC1 doesn't have the corresponding MAC address. So what it will do is, it will populate the destination MAC field as F, which is nothing but F denotes the broadcast. Alright. In the frame structure, we have a field which is called as type. That field denotes whether IP header is encapsulated or the ARP header is encapsulated. Since this is a F and PC doesn't know the corresponding MAC address, it must send ARP request to get the corresponding MAC address. Alright. So frame structure, destination MAC is F and source MAC is A. And if you guys remember the flow chart which we discussed yesterday, let me quickly open that. First, you have entered the ping and the PC done the AND operation. And in this scenario, they are in two different subnet. Correct? It comes here. Now it checks for the default gateway. Now let's quickly have a look if you have the default gateway configured. Show IP. I have my IP address and default gateway configured. Yes, so the default gateway is configured. What is the next step? It checks the ARP entry of the gateway. Previously we checked the ARP is empty. So ARP present? No. Now it is going to send the ARP request to the gateway IP address. Why? Because a broadcast cannot go beyond its subnet. Let me show you that. This is 10 subnet. Only till here this is 10 subnet. So when the broadcast is generated, it cannot exit the 10 subnet and it cannot directly go to 20. We need a person who is kind of like a mediator, kind of a gateway, which is nothing but the router. Now PC is going to send the ARP request to the gateway IP. Alright. But before that, the ICMP header is generated. In that, the IP field will automatically get populated. your source IP is going to be 10.0.0.10 and the destination IP is going to be 30.0.0.10. This IP header and this ICMP headers, these two headers will never change throughout this process. Only this frame structure and ARP header changes. Fine. Now let's populate the ARP. Now the PC doesn't know the corresponding MAC address for 30.0.0.10. Hence, I'm initiating a ARP request. Hey, who has 30.0.0.10? Sorry. Now the PC is sending the ARP request to its gateway. Correct? It is not going to send the ARP request to 30 because that is in different subnet. Now the ARP question will be, hey, who has 10.0.0.1? Fine. Now that ARP request comes to the switch. We all know that when switch receives a packet, it is going to do the broadcast at the first time. It does the broadcast excluding the originating port and the broadcast received at R1. And what R1 does, it is going to respond, hey, I am 10.0.0.1. Once that packet comes back, switch, see the basic functionality of switch is source MAC learning. Whenever a switch receives a packet, immediately it stores the source MAC and the corresponding port number where it is getting connected. When the ARP response comes back from R1, switch knows where 10.0.0.10 is connected. It will send it back. Fine. So before getting into ARP response, let's fill the ARP request here. So IP header over. For your ARP request, your source IP is going to be 10.0.0.10 and your source MAC is going to be A. And what is the target IP here? It's a gateway, 10.0.0.1. And what is the target MAC? You don't know. So only you are sending ARP request. Now that ARP request has been forwarded to R1. When R1 is sending it back, the field gets changed. ARP reply from the router to the PC, the field gets changed like this. Now what will be your source IP? 10.0.0.1. What is your source MAC? Let's assume the MAC address of R1 is C. What is your target IP here? 10.0.0.10. And what is your target MAC here? A. Alright, now this ARP response reached this PC. Now what this PC will do is, now it will send the ICMP echo request. So far the ICMP echo request haven't left the PC, because if you want to send the ICMP echo request, you should be knowing the IP as well as MAC. You should be knowing the physical address as well as the logical address. Now PC received it and then it will send the ICMP echo request to R1. I hope so far it is clear. Now R1 received the ICMP echo request. Now R1 opens and now it checks, okay, the source IP is 10 and the destination is 30. R1 will not edit anything in the IP header. Instead, again it is going to follow the same process. Now R1 is having a look at the destination IP 30.0.0.10. Now whenever a packet is received on the router is going to check three things. Is that network a directly connected interface to me? Second point, do I have any static route to reach to that network? And third, do I at least have a default route? In this scenario, 30 network is not a directly connected one. We can quickly have a look here. Let's do show IP route. See, first condition failed. It is not a directly connected. Second condition is satisfied. I have introduced the 30 subnet with the help of 20 as the next hop. Now what this router will do is, now it will check, do I have the corresponding MAC address for 20.0.0.2 If I have the corresponding MAC address, then I will directly forward the ICMP echo request to R2. If not, I'm again going to initiate the ARP request to get the corresponding MAC address of 20.0.0.2. Fine. In this scenario, let's assume R1 has the corresponding MAC address for 20.0.0.2. So the ICMP request reached here. And what R2 does? Again, it is going to do the same thing. Now it is going to check, is 30 is a directly connected network? The answer is yes. What is the destination IP now? It is same because the destination and source IP never changed in the IP header. Now R2 will check, do I have the corresponding MAC address for 30.0.0.10? If the answer is yes, it will forward it. If no, again the ARP request is going to get generated. Again, let's assume R2 knows the corresponding MAC address for 30.0.0.10. So the ICMP echo request reached here. In the echo reply, the fields get changed. I believe so far it is clear. If not, please leave a comment in comment section. I'll explain it one more time. This is ICMP echo reply. What is the destination MAC now? A. What is the source MAC? B. And here what is the source IP? 30.0.0.10. And what is the destination IP? 10.0.0.10. Do you guys think ARP will come into picture here? The answer is no, because whenever the switch receives a packet for the first time, it is going to store the MAC address. Also, this PC received a request from gateway, so the PC will also have the corresponding MAC for 30.0.0.1. So in the ICMP echo reply, the ARP will not come. Clear? And that's it. Let's say if for some reason the corresponding MAC address is deleted or the ARP cache got flushed, then ARP request will be initiated again. What about this ICMP header? See, ICMP header is a very simple format. It is going to have code and reply. Some codes, based on the codes, we can check if it is a echo request or echo reply. Those things will quickly check it in the packet capture. I believe so far it is clear. Now let's quickly do the ping and we'll capture the packet, setting the packet capture here. All right, in this interface, I initiated the capture. Let it go on and let's initiate the ping. Let's go to PC1 and let's ping. .0.0.10. Let's wait for, okay, yeah, it is going. Let's stop this. Let's go back to the Wireshark. Let's stop this. Initially, if you guys remember, at the starting we checked the ARP cache of PC1. It was empty, correct? See, this is the question. Who has 10.0.0.1? Let's open this packet and decode it. See, same thing will be mentioned here. Your source IP is going to be 10.0.0.10, which is PC1, and your target IP is 10.0.0.1, which is your gateway. All right, and it is asking who has 10.0.0.1. Now this is the reply. This is the reply from your gateway. So the sender IP is 10.0.0.1 and the target IP is 10.0.0.10. After the PC received this reply, after that only it is sending the ICMP request. That's it, guys. So this is what we must be clear. So the ICMP cannot be sent directly. First, it should know the corresponding IP and corresponding MAC address. Now, if you check the ICMP, we have the frame. In the frame, we have the destination MAC address, source MAC address, and see, this is IP header. In IP header, you can scroll down, check here. We have source and destination. This source and destination never changes. Only when we receive the ICMP echo reply, it will get changed. See, as I said earlier, the ICMP packet contains two things, type and code. The type is 8 and 0, which denotes ping request, ICMP echo request. If you open any reply packet, type is 0, code is 0, which is ICMP echo reply. I hope this is clear. Now let's quickly check how this one replies. Alright, let's capture this interface so that we can see the inbound and outgoing messages. Start capture. I have started the capture. Let's quickly delete the ARP cache. Okay, clear ARP. I have cleared it here. In PC2, let's check ARP, show ARP. Clear ARP, fine. Now let's do the continuous ping again. Ping 30.0.0.10. Let me make the count as 5. Success. Fine. So let's open the. So this is the packet capture on the other side interface. Here we can do the packet filtering. Let's search for it. Now I'm going to search for IP address 30.0.0.10. Now this is the reply. In the reply, what is going to be a source? It is 30.0.0.10 and the destination is 10.0.0.10. Same thing which we given here. This is the ICMP echo reply and the source IP is this one and the destination is this. I hope this is clear, and if you guys have any questions, please make a comment. Thank you so much.